You've got a company website, hundreds of pages, documentation, FAQs, product descriptions, and somewhere in all of that, the exact answer your customer needs right now. But they can't find it. Your support team can't find it fast enough either. And if you throw a generic AI chatbot at it, well, it just starts making things up. What if there was a way to point an AI agent at any website, let it read and understand every page, and then answer questions about that content, only that content, with a source link to back up every single answer? That's exactly what I built. It's called WebRAG. And in this video, I'm going to show you how it works, why it's built the way it is, and how you can get your hands on it today. WebRAG stands for Web-Page Retrieval Augmented Generation Agent, which is a mouthful, so let's just call it what it does. You give it a website URL, it crawls the site, reads every page, breaks the content into smart chunks, converts those chunks into something called vector embeddings, which are basically a mathematical way of encoding meaning, and stores them into a vector database called Pinecone. Then, when someone asks a question, WebRAG searches the database for the most relevant chunks, hands them to a language model along with the question, and the model responds with a cited, grounded answer. No hallucinations, no general knowledge, just answers that come directly from the website, with a source link for every single one. The whole thing runs inside n8n, an open source automation platform. No custom application servers, no extra orchestration layers. One workflow, that's it. Before we get into the architecture, I want to give you a quick sense of what went into this. WebRAG has over 90 nodes in n8n. It handles robots.txt compliance at 4 separate stages in the pipeline. It has dynamic chunking that adjusts based on actual page content, and it's fully multilingual, which we'll get to in a moment. It maintains its own vector index automatically, cleaning up stale and orphan data after every run. This wasn't a weekend project. This was built to work properly, not just to look good in a demo. Let me give you 5 situations where WebRAG does exactly what you need. First, customer support. Index your product docs and help center. Your customers and your agents get instant, sourced answers without digging through pages. Second, sales prep. Before a discovery call, point WebRAG at your prospect's website. In minutes, you have a grounded brief on their products, messaging, and positioning. No more skimming 10 pages before a call. Third, due diligence. Index a target company's public site, their terms, their about pages, and run a structured set of questions against it. Every answer is cited. Every source is traceable. Fourth, developer documentation assistance. Index your product's doc site and give your developers a chat interface that answers their questions with links to the exact page. And fifth, my personal favorite, internal knowledge retrieval. New employee? Point them at the company website and let them ask anything. They get grounded answers, they stop bothering the team, everybody wins. One website, one knowledge base, one grounded AI agent on top of it. Let's walk through how WebRAG works under the hood. 4 stages. Stage 1. Intake and risk validation. You submit a URL via a web form. The pipeline normalizes it, checks it against a block list of unsuitable domains, then fetches and fully parses the site's robots.txt, every allow, disallow, and crow delay rule, using WebRAG's own bot user agent. If the site says no crowers, the whole thing stops. Hard stop. No arguing with it. Stage 2. URL discovery. WebRAG finds the sitemap from robots.txt first or by probing common paths. It handles standard sitemaps and sitemap index files. No sitemap at all? It falls back to a depth tree link row. Homepage links, then links from those pages, then one level deeper. All URLs are filtered, deduped, and scope checked before entering the queue. and a cap of 200 URLs is applied at the duplication, so a single run never overwhelms the system with more load than it can reliably handle. That's especially important on local setups running n8n, Ollama, and embedding model all on the same machine. Stage 3. The ingestion pipeline. For each URL, WebRAG fetches the HTML, strips all markup and scripts, and extracts clean text. Before touching an embedding model, it runs a quality gate, minimum length, adaptive content checks, and boilerplate detection. Pages that fail are silently skipped. The pages that pass get chunked using a dynamic window based on actual content volume. Before any embedding happens, WebRAG checks Pinecone to see which chunks already exist and whether their content has changed, so only new or modified chunks proceed to the embedding model. Those eligible chunks are then embedded in batches and inserted to Pinecone. Unchanged content never touches the embedding model at all. Stage 4. The chat interface. A question comes in, WebRAG embeds it, queries Pinecone for the most semantically relevant chunks, assembles a prompt with the retrieved context and conversation history, and calls the language model. The system prompt explicitly forbids answering from general knowledge. Every answer comes with a source URL and page title. Now, I could have built this the way most RAG templates are built. Fixed chunk size, basic sitemap parsing, a robots.txt check that's basically decorative, and English-only content processing. That would have taken about a quarter of the time. But I didn't because those shortcuts cost you later. Fixed chunking means short pages get over-fragmented, and long pages lose semantic continuity across chunk boundaries. WebRAG uses dynamic chunking, and here is where it gets interesting. For languages like Japanese and Chinese, where words aren't separated by spaces, the chunking strategy switches automatically to character-based sizing. The system detects the structure of the text itself, not just the declared page language, and applies the right approach. That's not a feature most RAG systems think about at all. Surface-level robots.txt compliance is both an ethical and a legal risk in business context. WebRAG enforces it at 4 separate points in the pipeline. Skipping the content quality gate means your vector database fills up with 404 pages, login screens, and JavaScript shells that produce nearly empty HTML. Those bad embeddings degrade every query. The gate removes them before they ever reach Pinecone, and it does this correctly across all scripts, not just English text. And automatic index maintenance means the index always reflects the current state of the website, not a growing pile of outdated data. Most templates just keep adding forever. That's not a knowledge base, that's a landfill. Every decision in WebRAG exists because it makes the output better, or more defensible, or both. WebRAG ships in 2 modes, and you choose which one fits your situation. Local mode runs everything on your own machine using Ollama. The embedding model is Snowflake Arctic Embed 2, and the chat model is Qwen 2.5 Instruct, 7 billion parameters. Those are my defaults and they work well. But if you already have a favorite Ollama model, you can swap either one out without touching anything else in the workflow. Your data never leaves your machine, no API costs. The trade-off is speed on a machine without a GPU. Cloud mode uses OpenAI for both embeddings and chat, currently GPT-5 Mini, which gives you faster inference and higher throughput. The trade-off is data going to OpenAI's API and token costs. Both modes share the exact same ingestion pipeline. They use separate Pinecone indexes, so there's zero cross-contamination risk. In production, these ship as 2 separate workflow files. If you are in regulated industry, working with sensitive data, or just hate recurring API bills, local mode. If you want higher quality, faster responses, and you are comfortable with cloud APIs, cloud mode. Both work, both are production ready, and both handle multilingual content out of the box. Alright, enough talking. Let me show you this actually working. I'm going to submit a URL to the ingestion form right now. I'm using a test site I built specifically for this demo, a clean site with a known number of pages, which makes the run summary easier to follow. Here's the Pinecone index right now, 0 vectors. Nothing from this site yet. I'm selecting full crawl mode so it will go through the entire sitemap. You can see the workflow firing. It's checking robots.txt right now. The sitemap has been found and parsed. It's splitting the URLs into individual items and starting to fetch pages. Each page goes through the quality gate, gets chunked, and the chunks get embedded and abstracted to Pinecone. And there's the run summary from node 39, the final node. This is the full audit output. Let me call out the key numbers. The total number of pages seen is 37. The total number of pages successfully indexed is 26. The total number of chunks written to Pinecone is 75. The quality gate pass rate is 87%, meaning 87% of the pages had enough clean, meaningful content to be worth indexing. And the Pinecone vector count, 0 before this run, 75 vectors now. Notice it breaks down exactly why each skip page was skipped. Fetch failures, quality failures, chunking edge cases, all categorized. That's not just a summary, that's an audit trail. That's the whole site, indexed and ready. And here's Pinecone now, 75 vectors. The entire site, embedded and stored. Now let me switch to the chat interface. First question, something factual. And there it is, a clean, cited answer. Source URL right there. Let's verify it. That answer came directly from that page. No hallucination, no guessing. Let me ask a follow-up. Notice it remembered the context. That's the session memory working. One more. Let me ask something the site doesn't cover. And it tells me it doesn't have that information in its knowledge base. A confident I don't know is worth 100 hallucinated answers. Here is something most RAG tutorials completely skip: automatic index maintenance. Every time you run an ingestion, WebRAG does three things after abstracting. First, it enumerates every vector currently in your Pinecone namespace for this site's hostname. Then, it compares that list against the pages it just crawled. Any page that has been removed from the site gets flagged as stale, and its vectors are deleted. Any old chunk belonging to a page that was recrawled but changed, meaning the new version is already in, but the old one is still sitting there, gets flagged as an orphan and deleted. The result? Your Pinecone index always reflects the current state of the website, not a growing pile of outdated data, the current state. And if you run in single mode, recrawling just one page, the stale detection is intentionally skipped so you don't accidentally wipe the rest of the index. Only orphan cleanup runs. That's a deliberate design choice, not an oversight. Quick overview of what you need to get WebRAG running. For local mode, n8n, which can run in Docker, Ollama with the Snowflake Arctic Embed 2 and Qwen 2.5 instruct 7 billion models pooled, or your favorite Ollama models, and a free Pinecone account. No OpenAI key, no cloud costs. For cloud mode, you swap Ollama for an OpenAI API key. The setup: import the workflow JSON into n8n, configure your credentials, create the Pinecone index with the right dimensions, 1024 for local, 1536 for cloud. Add your contact email to the HTTP headers so you are a responsible crawler, and activate. There is a full quick start checklist in the documentation. When you buy WebRAG from my Gumroad shop, you get the workflow files and everything else you see in this video. The documentation walks you through the setup step by step. The barrier to entry is genuinely low if you are already comfortable with n8n. Now, a question that naturally comes up. The workflow is running, the knowledge base is built. How does this actually fit into what my team does every day? Simpler than you might expect. WebRAG gives you two URLs. The first is the ingestion form, operator territory. One or two people in your organization use it to crawl a new site or refresh the knowledge base when content changes. A bookmark is all the access management you need. The second is the chat interface, what your team or your customers actually interact with. Three ways to deploy it. Share it as a direct link and pin it in Slack or Notion. Embed it as an iframe in any portal or help desk. Users see a chat window, nothing else. Or call it via API and build whatever front end you want on top. No developers needed for the first two. The chat is live, the knowledge base is ready, and your team has a grounded AI assistant for that website on day one. If you are on n8n cloud, these URLs are publicly accessible out of the box. On a self-hosted setup, accessibility depends on your network configuration. Before I wrap up, what WebRAG doesn't do, because that matters too. It doesn't support JavaScript render pages. Single-page apps where the HTML shell is basically empty until JavaScript runs will return very little content. Public pages only. Anything behind a login or a paywall is out of reach. If a site uses bot protection that blocks automated requests, affected pages get soft-skipped and reported in the run summary. You will know exactly what didn't make it in. In full crawl mode, legal and policy pages, privacy policies, terms of service, are excluded by default to keep retrieval quality high. Single mode handles those when you need them. And by default, WebRAG caps each run at 200 URLs, enough for the vast majority of sites. For sites that need more, the cap is single constant you can raise in the workflow. These aren't deal breakers for most use cases, but if you are evaluating for a specific situation, I would rather you know upfront. WebRAG is available right now in my Gumroad shop, link in the description. You get the local workflow, the cloud workflow, and the full documentation. If you are a business looking to deploy this, or you would like to work with me directly, that link is in the description too. If this video was useful, subscribe and drop a comment telling me what website you would point this at first. Genuinely curious. See you in the next one.